Hi students, I decided to just make a video explaining this problem because I think it's a bit easier than trying to type it out. Also, I noticed that if you look at the PDF of solutions that we provided for these, it's a little bit funny because this problem talks about, or the solutions show that part B is finding the trapezoidal approximation, which is not what your part B is. Your part B actually is this question C, which is it an overestimate or underestimate? So the typed up solution from the AP, in the PDF, you're going to want to look at part C, which is bizarre, but I'm going to talk you through it. So we were given originally that we had this function, f of x was equal to cosine of root x. And they've given us the first and second derivatives of that. And then, so let me just come back and look at this. So yeah, f of x was cosine of root x. We're approximating the integral between 1 and 3 of f of x. So integral between 1 and 3 f of x dx. And we're asked here, is a trapezoidal sum an overestimate or an underestimate? They've given us first and second derivatives. Well, first derivative is going to tell us increasing or decreasing. And second derivative is going to tell us concavity. So between 1 and 3, I could use, and this is definitely a calculator problem, so I'm going to put in the graph of my second derivative and look at it between 1 and 3. So first thing I want to do is make sure my calculator's in radian mode, but I'm also going to add a page that's a graph. And again, I want to make sure that my graph is in radian mode. Come on. There we go. So when I'm graphing, I want to look at my settings and make sure that my graphing angle is also radians. So even though it says radians up here, you just want to make sure that you're also in radians mode here. And I want to look between 1 and 3 of the graph of sine of square root of x divided by 4x square root of x. It didn't like that time. All right. I feel like I have 1, 2, nope, that's enough parentheses, minus cosine of square root of x divided by 4x. Okay, that is obviously values that are very small. I'm looking between 1 and 3. So I'm going to actually go into my table to see values between 1 and 3. So here's my x values. They look like my y values look like they're all positive. Let's just zoom into our graph a little bit to see. So Control T to get rid of the table. And now I'm going to go into my menu and change my window. And I want to go between 1 and 3 on my x-axis. And I'm going to go between -0.2 and 0.5, let's say. Okay, so certainly my second derivative is always positive. So from the graph, we know that f double prime is greater than 0 for 1 less than or equal to x less than or equal to 3. That means f of x is concave up. And if I think about trapezoidal sums, so I'm not sure why this is writing so thick. I'm going to thin it down a bit. If I have something that's concave up and I'm doing a trapezoidal approximation, well, that means that I'm going to have this value here, this value here, yikes, here to here, here to here. No matter whether I'm on, like whether the curve is decreasing or increasing, it doesn't matter. My tangent lines, secant lines connecting 2 points are always going to be above the curve. So my trapezoidal approximation is an overestimate. So these are the two things you need to say. That because the second derivative is positive, it's concave up, and the trapezoidal approximation is an overestimate. If we go in and look at the solutions, they say the same thing, concave up. Trapezoidal sum is an overestimate because it's concave up. So, and like I said, increasing, decreasing doesn't affect the trapezoidal sum. So you might want to go back and think about right Riemann sum, left Riemann sum, and which one we care about. Do we care about concavity, or do we care about increasing, decreasing to determine whether they're overestimates or underestimates? So I would draw some pictures and think about those sorts of things.